All right, here we go. Unit 2, lesson, section 2.1 and 2.2. And going to run through the first few boxes here. And the first one is polynomial. What is a polynomial? And you can see over here on the right that it says it's an expression of the form, and that has all this writing down here. And really what we want to be pulling out, it's probably easiest to start with just a generic example of what a polynomial is. So if we had 3x squared minus 2x plus 8, this here is a polynomial. And now with that kind of in mind, let's look at why that is. So we've got an x to a certain power, x to some power right here. Specifically for us, it's x to the second power right now. And then notice how on the x's, each time on down, each term is one lower. So we've got minus 2x, and you could think of this as to the first. Keeps on going until we get to, so actually that would be this one right here, because that's x to the first. And then after that, x to the 0, if you want to think of this as x to the 0 right here, you could do that, because what is anything to the 0 power? Well, it's just 1, and 1 times 8, that's 8. And there we go. That's your constant on the end. Now notice that it says n, that that number here has to be greater than 0. Because if we get to having, let's say, 2x to the third, that to the positive third, 2x to the third plus 5x squared, and so on and so forth, over x, or over whatever it is there, where now we're going to have, let's say, x to the fifth. I don't know. Something that gives us a negative exponent on the x here. Now we're no longer where n is greater than 0. Now we're into something called rational expressions, and that's a little bit different than our polynomial expressions right now. So all of what we dealt with so far, where we are factoring and so on and so forth, those are, for all intents and purposes, going to be your polynomial expressions. Now, one thing that's probably a bit off on the notes here is that a, what looks like our coefficient here, that's going to be changing. So this part, let's kind of ignore that for the time being, because their coefficients can change into whatever they are. Really what we're focusing on is the x value that's going on, and this is what the A is talking about. To be more explicit, is which term we are writing about. So our first term, our second term, third term, because we do need to realize that even if the coefficient of a specific term is 0, that it's still there. And kind of here's what I mean by that. We might write 3x to the fourth minus x squared plus 7, but we ought to realize that there are still the terms of, so 3x to the fourth plus 0x to the third. Notice how that one, it would fit in between our x to the fourth and x squared here. So minus x squared, and then again plus 0x. That one kind of got left out as we simplified, and plus 7. So these terms here are still necessary to realize that they're there. When you're simplifying, you'd get rid of them, but if we're doing something where we're dividing, for example, we need to recall to add these ones in here. All right, that's polynomial expressions. Now terms. Terms are going to be just as you know them right now. Whenever you have something being added or subtracted here, you've got a new term. Back on the ones we were just using, 3x squared is a term, negative 2x is a term, and 8 is a term. All are different terms here, again, just separated by the adding or subtracting. Coefficients, been using that term already, but those are the numbers out in front, the what is being multiplied by the x squared, the x, and so on. And that last coefficient really is a constant. So over here we had that this our coefficients here are 3, -2, and then a constant of 8 at the end. So coefficients are just the numbers that are being multiplied by our x term, so x squared and x. All right, coefficients. The next one is leading term, leading coefficient. That's going to be whatever one is the first when they're in their sequential descending order. So here's our leading term on this one here, 3x squared. It's higher than x to the first, it's higher than x to the 0. And if we were to have an expression where maybe we had them written out of order, and so x to the 5th plus 7x squared minus 8x to the 12th, or 11th rather, then we would reorder these because our leading coefficient really is the -8x to the 11th plus x to the 5th plus 7x squared. Here's our leading term. So our leading term and our leading coefficient would be a -8. All right, that's leading terms and leading coefficients. Lastly, just kind of for the terminology we need to get used to is degree, which I'm assuming a little bit that we're familiar with already. Degree is the exponent. So this is an 11th degree term right here, an 11th degree polynomial, because the highest degree is to the 11th power. Up here we have a second degree polynomial, which we call a quadratic. This one here would be a 4th degree polynomial, which is a quartic. And if it was to the third, that would be cubic. But the highest degree, and again, degrees based on the biggest biggest exponent for your variable. All right, I hope that helped.